No rain, no water. The Rhine is increasingly difficult to navigate.
Of course, pressure is quite high.
Could low-water vessels help keep supply chains moving?
There are more and more companies asking for low-water optimized vessels.
How do they work? How far has the research come? And why are there still so few of them? Only a handful of containers are still on board. Add any more weight and the vessel could run aground. Water levels on Europe's most important inland waterway are still hovering around record lows. In Duisburg, water levels are more than 2.5 meters below the long-term average. So, can ships be designed to keep operating when water levels are critically low? On a lake just a few kilometers from Duisburg, scientists are testing what might be possible.
We have the measuring equipment for the propeller load, for the propeller rate of revolutions, the actuation for all 6 rudders.
May look like a toy, but appearances are deceptive. This scale model represents a low-water vessel. The actual ship is around 10 times larger and already operating on the Rhine.
This is a large vessel, 135 meters long, more than 17 meters wide. It is the largest possible vessel to operate on the Rhine.
Researchers are collecting data on how the vessel behaves when maneuvering, because low-water vessels are designed differently. A conventional river vessel sits relatively deep in the water and has a large propeller. This makes it highly fuel efficient under normal conditions. A low-water vessel, by contrast, is designed to be wider, longer, and lighter. It uses smaller propellers that can operate in shallow water. But this different design also changes the way the vessel is maneuvered. The data will be later analyzed in a simulator.
Of course, the maneuvering behavior of a ship like this changes with the underkeel clearance and available water depth. And what we've seen at the lake are tests with a scale model where we do a lot of measurements on maneuverability. Then these test results are analyzed and mathematically modeled for such simulators.
Interest in low-water vessels is growing. The shipping company HGK began redesigning parts of its fleet following the last major drought 8 years ago.
2018 made us think about alternative vessel designs. We were able to build in total 11 new build vessels just for low water periods.
When water levels fall, these vessels have a clear advantage. Because they have a shallower draft, they can carry up to 3 times as much cargo in low water as a conventional vessel. When water levels are low, every centimeter of additional draft matters.
You can say as a rule of thumb, every 10 centimeters do mean up to 150 tons. So talking about 50 centimeters of advantage, we're talking about 750 tons we're able to provide to our customers.
But there's a downside. Because of their wider hulls and smaller propellers, low-water vessels use around 30% more fuel. Under normal water conditions, that makes them more expensive to operate. For shipping companies, it is a delicate balancing act.
We need to ensure that the fuel consumption needs to be as low as possible as well, because everybody is looking for sustainable transport and a sustainable transport mode. And that's why we need to combine low water optimization and at the same time a sustainable vessel design.
Low-water vessels can keep moving and help safeguard supply chains when conventional ships are reaching their limits. But ultimately, even these vessels need water beneath their keels. And because of climate change, that water could become increasingly scarce.